Okay, we're going to talk about resistors in series and in parallel. All this is when we have a whole bunch of different resistors or light bulbs or whatever we want that has a resistance. How they're all hooked up together is essentially what we're doing right now. So if we're going to talk about resistors that are hooked up in series, the definition up there says when two or more resistors are connected along a single path. I actually always think about when I was a kid, we'd have strands of Christmas lights where if one of the lights burned out, the whole thing went out, which is essentially what would happen in series. It's one light bulb provides the resistance, but once that connection breaks, then the electrons don't flow through your wire anymore. So I've got a diagram here of what that would look like, and again I've used the IB symbol for resistors, where it's just the little box. Again, if this was AP, it just looks like that. Okay, not a big deal. It's the same crap. Okay, so here's our battery, whatever that voltage is coming out of the battery. Okay, and we're going to use conventional current, so it's the direction that the positive charges would flow. So it's moving this way. So here's the current, and it would pass through each resistor, and then the current coming out the other side would be the same as the total amount that went through here, all the way through. All through 1, 2, 3, all in a row. So you can think of series things as things that are in a row. Okay, now the current flows through each resistor, and the voltage drops across each resistor. So let's just think of it this way. If this was a 9-volt battery, and these resistors were all equal resistances, then across the first resistor, we would lose 3 volts. And we'd be down to 6. After this resistor, we'd lose 3 more volts, and we'd be down to 3 on this side. And after this resistor, we'd be down to 0. We would use up the whole entire voltage in the loop. Okay, and that's going to come in handy when we actually start solving problems with these. But for now, we're just figuring out how to add together the resistances. Okay, so the total voltage has to be the sum of all the voltage drops across each one, and all those voltage drops are equal to the current times the resistance. So the total amount of voltage is equal to the current times the total resistance. So in this case, with series, in resistors in series, the total resistance is R1 plus R2 plus R3 plus however many resistors you have. Okay. Now this symbol might just say RS, especially for AP. It might just say RS, which is this resistance in series. Okay, but it's the total resistance. Okay, so series is relatively easy. Take all of those resistances and add them up. It's just that simple. Okay, all right. Parallel is a little different. Okay, and this is more common. Okay, parallel is when 2 or more resistors are connected along multiple paths. Now this is like the lights in your house, because if one light went out in your house, you wouldn't want all the other lights to go out. Okay, so when you hook something up in parallel, it allows the current to flow through different paths. So again, I got a picture here. The total voltage comes out here. Okay, and the current travels through. And once it gets to this junction, it can go 3 different ways. It can either go to the top one, or this one, or this one. But when it comes out the other side, the current has to flow the same as what it was when it came in, but the current can split into 3 different places. Okay, so the total current into a junction has to be the total current coming out, but the current will split depending on the resistances. Now this is a key idea right here. It says electricity will take the path of least resistance. So if you put an extremely large resistance here, then the current's pretty much going to split 2 ways. Okay, but if all these resistances were equal resistances, then the current would split equally 3 different ways. Okay, so in this case, we're a little more worried about the current. The current into a junction has to be the current that goes through this path, plus through this path. That's the total current. So the total current is equal to the voltage divided by the total resistance. And you'll notice that the resistance here is on the bottom. Therefore, in parallel circuits, it's always the inverse. So you've got 1 over the total resistance equals 1 over resistance 1, 1 over resistance 2, 1 over resistance 3. That's going to add up. And then don't forget that this is inverse. Okay, it's a slightly different equation for adding things in parallel. And again, you might see this as RP instead of RT if you're on AP. Okay.